Welcome to our second grade math lesson 7. Today we are going to be looking at some word problems as well as fact families that we talked a little bit about last week. So I'll share my screen with you. Okay, second grade math. So we're going to be looking at fact families a little bit closer this week. So we're going to start out with a review. This is a fact family, and we can also look at it as a part whole with two parts making one whole number. So if we look at this triangle here, we have 10 at the top. 10 is our whole, and it has two parts, 6 and 4. And we know that when we put those two parts together, 6 and then 4 more, it's going to make our whole of 10. So 6 and 4 make 10. 6 is a part, 4 is a part, 10 is a whole. So out of this triangle, we can find 4 different equations. We're going to be finding 2 addition equations and 2 subtraction equations. And all 4 of those equations together make a fact family. And the reason they make a fact family is because all of them use these 3 numbers and show those 2 separate parts creating a whole. So the first equation we're going to come up with is an addition sentence. And you guys, I think, will get it because I just said it. So see if you can remember, what is one way that we can make an addition equation out of these numbers? We know addition is the plus sign, and we put those 2 numbers together. We could do 6 plus 4, right? I know if I put this part 6 with this part 4, it is going to make my whole 10. What's another way I could write that addition equation? I know that in an addition sentence, I can move around these numbers anyway, and it's always going to still equal the whole 10. So I could put the 4 first. I could say 4 plus 6 equals 10, right? So I have 2 addition sentences, but they both have the same parts, right? They both have 4, they both have 6, and the same whole. And we know in an addition sentence, our answer is our whole. But that's not the case for subtraction or minus sentences. In a subtraction sentence, our whole is actually at the beginning because we have that large group, that whole that we begin taking away from. So for a subtraction sentence, we could say 10, right, minus, so I use my whole, and I can take away either one of these parts. So I'm going to take away the part 4. So if I have 10 and I take away 1, 2, 3, 4, what am I left with? 1, 2, 3, 4, 5, 6. Just like this triangle shows us, 10, take away 4, there's just going to be 6 left. And for my other subtraction sentence, if I started with 10 and I took away 6, what do you think my answer would be? 4. So I know this is still tricky, guys, and we're still learning this. We're going to keep talking about fact families over the next few lessons. But if you just look at this closely, notice that you have your wholes at the end for addition problems. You have your wholes at the beginning for subtraction problems. But this is a fact family because these 3 numbers repeat the whole time. You have a 4 in every single equation. You have a 6 in every single equation, and then of course a 10, your whole in every single equation, and you have 4 of them. Okay, I hope that was a good review. So we are going to look at 2 story problems today. I'm going to read it a few times for you first before we begin working. These story problems are going to really require that you think about fact families, okay? The answers are not going to be as easy as they've been in the past, and I'll show you what I mean. So Georgia has 4 dolls. Okay, so I have my 4 here. Eric has 3 dolls. How many dolls do they have together? Can you figure it out? I wrote my sentence. I know it's asking me how many dolls I have together. So this is an easy one. We're building up to harder ones. Georgia has 4 dolls. Eric has 3 dolls. How many do they have together? It wants me to put those together and tell them my whole, my total. So 4 plus 3 equals what, guys? We can draw it. 1, 2, 3, 4. Here's Georgia's 4 dolls. And Eric has 3. 1, 2, 3. 4 plus 3 equals what? It equals 7. If you counted them up, you got 7, you are correct. Eric and Georgia have 7 dolls altogether. So that one wasn't too hard, right? Now I'm going to write these equations, or I'm sorry, these story problems on the same page so that you can see. This is a very similar story problem, and we're still going to be talking about Georgia and Eric and their dolls, but the question is different. And that's why it's so important to really think about the words you are hearing and the question that is being asked in a story problem, because sometimes story problems can look the same, but they're asking a different question. You have to be sure you are answering the question that's being asked. So the first question was, how many dolls do they have together? And we were right. They had 7. But listen to this one. Georgia has 4 dolls and Eric has some dolls. So in this one, listen, Georgia has 4 dolls and Eric has some dolls. Okay, do we know how many dolls Eric has in our new story? We do not know how many dolls Eric has. We know how many Georgia has. It says Georgia has 4, but it just says Eric has some, and we don't know how many some is. But if we keep reading, we find out some more information. They have 7 all together. How many dolls does Eric have? So in our first question, it wanted to know how many we had all together. But in this question, in this story problem, it's not asking how many we have all together. It's asking how many dolls does Eric have? So let's see if we can draw a picture of that. We know Georgia, and I gotta move my screen so you guys can see. Okay, here you go. I pulled up here my triangle. That way I can see my part whole. So we're pausing. We're jumping back to the first one. Georgia has 4 dolls. Eric has 3 dolls. How many dolls do they have together? 7. So I know 7 is my whole, and 4 and 3 are my parts, right? Part, whole. Okay. Now here, Georgia has 4 dolls, right? But that's just a part. Eric has some. We're not sure how many he has, so I'm not sure what goes here. But I do know that they have 7 all together. So all together is letting me know that that's my whole. So I'm going to put 7 up top. Here's my whole, and here's my part. So my question is, how many dolls does Eric have? Okay, and that's what's going to go here. So I can do it this way. I can take my whole, right? Remember, if we go back to those fact families, we can figure out a part by using a subtraction sentence. I'm going to take my whole, and my whole is 7. We have 7 dolls, Eric and Georgia, all together. And I'm going to take away Georgia's part. So I have my whole. If I take away Georgia's part, which is 4, I'm going to be left with Eric's part, right? If there are 2 parts that come together to make a whole, and I take away Georgia's part, I'm going to be left with Eric's part. So that's how I'm going to figure that one out. So my equation is 7 minus 4 to figure this one out. So let's draw that, 7 minus 4. What am I going to start with? Don't think about it too much. I know this is a lot, but 7 minus 4, you guys know how to do this. What am I going to draw first? I'm going to draw 7. I drew 7, right? And now it says minus. Minus means take away. I'm going to take away how many? I'm going to take away 4. 1, 2, 3, 4. 1, 2, 3, 4. Did I do it? Did I draw 7 and take away 4? I did. So what is my answer? How many dolls does Eric have? This 7 represented all of our dolls. I took away all 4 of George's dolls, and I'm left with what Eric has. What does Eric have? He has 3 dolls. And I can fill my part just like we had in this sentence up here. These 2 problems are part of a fact family. Notice the numbers are the same. Good job, guys. I know that one is a bit complicated, but we are going to keep working on part-whole relationship for fact families, and it'll get easier each time. Thank you so much.